Hello again, class. In this video, we are going to talk about finding the area of rectangles with whole number sides. Before we begin doing that, I need to go over, I think, a few things, okay, so that we understand them and they're clear to us. And that is the three types of dimensional measurements that we could use. And the first one being one-dimensional measurement. And one-dimensional measurement simply is something like a line. Okay, and that line might go on forever, or it might have a starting point and an ending point. But when we measure the distance, it's just one dimension. Okay, whether it's going in this direction, that direction, or whether your line takes a curve, you're still measuring one dimension. Okay, the other type, or another type of measurement, would be two-dimensional measurement. Okay, and two-dimensional measurement, as opposed to a line, would be like a surface. Okay, like countertop, a wall, a floor, something that has two dimensions. Okay, in this case, I've drawn a rectangle. Maybe that represents a tabletop. And let's take a look at this tabletop. It is 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5 units tall. Okay, and so we would say that the surface area, okay, or the area of that, and let's make that feet, the area of that tabletop, it's a big table, okay, is 45 square feet. Okay, and so I need to make another point right here. In a one-dimensional measurement, where we go from point A to point B, and let's say that this measurement is also 45 feet. Okay, but it's just 45 feet. We're measuring in one dimension. Okay, here we're looking at square feet. Okay, so in other words, something that is 12 inches by 12 inches, or 1 foot by 1 foot, and we're saying how many of those feet, those square feet that are 1 unit by 1 unit, would fit inside of my table. So I've gone ahead and connected the dots here to just prove my point. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5. And I'm going to go across because counting by fives is something that I'm better at than counting by nines. Okay, so I'm going to see how many total squares, because each column contains 5, are in this tabletop. 5, 10, 15, 20, 25, 30, 35, 40, 45. So the tabletop is 45 square feet. And remember, I can count them individually, but since it's a rectangle and I've got equal columns and equal rows, the easiest way for me to do that is just to multiply. 9 times 5 is 45. The third type of dimensional measurement, one that we're not ready to get into yet, would be three-dimensional. And my paper only has 2 dimensions. I can't show you a 3-dimensional measurement on my paper. In order to do a 3-dimensional measurement, I actually have to bring an object into the picture. And what you'll notice as I set the object down, it has a dimension of length and width, okay? But it also has a third dimension of height. So if I were to look at the volume of this, I would have to use length times width and then also multiply it by the height. Okay, so let's do a quick review. We have linear one-dimensional measurement is exactly that. It just goes in one direction. Okay, it might curve, it might slant, but I'm only measuring one track. Okay, in two-dimensional measurement, I'm looking at an area of volume. There's a pretty big shape. 1, 2, 3, 4. by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if I were to figure out the volume of that, again, it's easier just to multiply these two numbers together. I can count by fours. If I can do that to 13, I think I can. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52. So I'm looking at a measurement for the surface area of this to be 52 units, okay? And they're square units, okay? Because each one is 1 unit by 1 unit, and I counted it and I came up with 13, okay? Now, one thing I want us to understand, okay, and this is going to help us when we start getting into fractional units, is that I can take and I can split this figure up. Okay, and here's what I mean. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm going to draw a line right there, okay? Because 13 is 10 plus 3, okay? So if I didn't know what 4 times 13 was, I could split this up into two shapes, and when I put those two shapes together, it's going to give me the total area. So one of these shapes is 4 by 10. So inside this section of the box, I have 4 by 10. 4 times 10 is 40. So that is 40 square units. And over here, I have one that is 4 by 3. And 4 times 3 is 12 square units. And if I add 40 plus 12, I get the 52 that I started with, okay, that I knew I was going to add up to. So I've multiplied, I've counted, I've split it up. All of those ways are ways that we can start solving these area problems. Before we go on, I want to show you one more thing, okay, before we stop the video. So I'm going to draw a box here. And I'm going to let that box represent a multiplication problem for a moment, okay? I know several of you like the lattice, and that's fine if you like the lattice, if it's successful for you. Okay? And one of the problems people have with lattice is drawing the diagonal lines correctly. Well, here's kind of a graphic organizer for multiplication that is a little bit simpler when it comes to the drawing portion, okay? And here's what I mean. So let's take a problem like 47 times 29, okay? And we want to solve that. Now in the lattice, you put the numbers here, I believe it is, and then you draw your diagonals, okay? What I'm going to do is I'm going to put my, let's take the 47 and put it on top, okay? And I'm just going to divide this in half both ways. Okay, so already that's all the drawing I have to do, no diagonals. And I've got 47. So basically what I've done is I've taken my area, my rectangular area, and I've divided it up like we did in the previous, it's not proportional, but I've divided it up into 40 plus 7. And I've got 29, and I'm going to divide that up as well, 20 plus 9. And so if I figure the area of each one of these individual squares and then combine them together, then what I have is the area of the total shape, which is 47 by 29. Okay, so let's do that multiplication. Okay, 4 times 2 is 8. But I have a 0 here and a 0 here because this is not 2, it's 20. This is not 4, it's 40. And here I have 9 times 4. Well, that's 36. And I do not have a 0 here, but I still have one here. So that's times 10, 36 times 10. And now let's go to this box where I'm doing 20 and 7. 2 times 7 is 14. And I have a 0 here, but none here, so I'm going to add one more 0. 2 times 10 times 7. And in this last box, I just have a 7 and a 9. 7 times 9 is 63. Now all I have to do is take those four numbers and add them together, and then I'll get the total area of this, which would also give me the answer to the multiplication problem. Great little graphic organizer. And something that kind of makes this easy is just to go ahead and add across, okay? Because usually we can do the addition across in our head. 800 plus 40, well, 800 plus another 100 is 900, so that would be 940. And that's the top. 360 plus 60 more, okay? Well, 360 plus 40 would give me 400 plus the 20 more that I need to make the 60, so I get 420, and the ones give me another 3, so equals 423. So now that I have this part here, and the bottom two numbers here, I can just add down. 0 plus 3 is 3, 4 plus 2 is 6, 9 plus 4 is 13, and my answer to the multiplication problem is 1363. And again, this is something that's going to be important for us to understand as we get into that fractional component of measurement. All right, hope this is helpful to you.